Inheritance in C++. In this video, I will cover the concept of inheritance in C++ programming language. Also, I will use some code samples in order to help you understand this concept better. The ID of the choice that I'm using is Xcode on a Mac OS. You can use any ID of your choice depending on what makes you feel more comfortable and which one is yours. One of the most important concepts in object-oriented programming is that of inheritance. Inheritance allows us to define a class in terms of another class, which makes it easier to create and maintain an application. This also provides an opportunity to reuse the code functionality and fast implementation time. When creating a class, instead of writing completely new data members and member functions, the programmer can designate that the new class should inherit the members of an existing class. In an inheritance relationship, we are dealing with an is-a relationship. For example, mammal is an animal, dog is a mammal, hence dog is an animal, as well, and so on. The class being inherited from is called the parent class, base class, or superclass. And the class going to inherit from the other class is called the child class, derived class, or subclass. So looking at this diagram here, you can see shape is our superclass or the parent class, and there are two child classes inheriting from the shape. This arrow pointing from the child to the parent is actually depicting the inheritance relationship between the two. Remember, the arrow is always pointing from the child, in this case triangle, to the parent, in this case shape. Look at the is-a relationship. You can say triangle is a shape. Also, in this case over here, you can say right triangle is a triangle. So as soon as you can use this and the is-a relationship exists over there, you have an inheritance. Look at this part. Square is a rectangle, and rectangle is a quadrilateral, and a quadrilateral is a shape. So you can see that relationship over here is depicted and the inheritance exists. A child class inherits both behaviors, member functions, and properties or member variables from the parent, subject to some access restrictions that we will cover very soon. Remember, these variables and functions become members of the derived class. Because child classes are full-fledged classes, they can of course have their own members that are specific to the class. A class can be derived from more than one classes, which means it can inherit data and functions from multiple base classes. To define a derived class, we use a class derivation list to specify the best class or classes. The class derivation list is defined like what you see. So class, name of the derived class, access specifier, and the base class. In this case, the access specifier could be of public, protected, or private. And base class is the name of a previously defined class that you are deriving from that. If the access specifier is not used, then it is private by default. Let's now move to the Xcode and review this concept as we just learned it. Consider a base class shape and its derived class rectangle, and we want to just develop the code for them. So the first thing that I'm going to do is I'm going to use the namespace standard as we always do. And let's define a base class. And here we have our class shape now. As you can notice, it's a very simple class. It has two protected members, width and height, and both of them have their own setters set up already. Now let's come up and create the derived class from this class. So here we will do our derived class. Let me just scroll up so you can see what's going on, and let's do it. So the first step is going to be definition of the class name. And remember, in this case, I'm creating a class like rectangle, which is going to inherit from shape. So the first thing that I put in is the name of the class that I want to create, which in this case is my rectangle. I put the colon after, and then I need to define the access identifier, which in this case I wanted to publicly inherit and inherit from class shape. So that is how I define my class over here. So again, let's go back to the slides and look at what we discussed. So we have the class identifier, then the derived class, which in this case was our rectangle, and then the access specifier, which we used public, and then the base class, which actually was the shape. So pretty simple, pretty straightforward. Now let's code this guy. So I will try to keep this as simple as possible since we just want to understand how inheritance works. So I'll have a public integer, let's say we get the area, so that we can show how everything actually works over here. And in the case of getting the area, what I want to do is I want to return the height times width, or let's put width times height. There you go. So that's what I'm going to return from here, and it should all be good. Okay, so very simple. As you notice, let me just scroll up a little bit. So here I had to set width, set height, while down here I'm not doing no setters, no getters for width and height. I basically am inheriting these two parameters from the shape class, and therefore they're available to me down here. Okay, so now let's go to the main, and within our main we want to create a rectangle object and call it rect. Okay, so now I have a rectangle object, and now I want to call and say, okay, on the rect, do the set width, and the integer I'm sending in is going to be, let's say, 5. So you can do whatever you want. So again, for the rect, excuse my fingers, I want to do a set width this time. And for the height, I'm going to give it a 7. So basically, so far by this line, I set the width by 5. When I run this line, it's going to go back to where the set width within the shape is working. And same again for the height. It's going to come back here and take care of it down there. Now, notice that what I want to do is printing the area of the object. So this is what exactly I want to do. And here I want to do the C out and say the total area is, and now I'm calling rect, and from the rectangle I'm calling the get area, which actually is ready to go right now. So remember that I didn't create no object of class shape, which is the parent class. I simply created an object of rectangle class. But when I call set width and set height, it comes here to rectangle and says, hey, you don't have those? Cool. Let's see if there is an inheritance. Comes up and figures out, yeah, I'm inheriting from shape in a public way. So I can go there to my parent and figure out what set width and set heights are, set them, bring it back, and print it. So just make this a little bit nicer, and let's run it now. And as you can see, the total area is 35, which is the multiplication over there. And just for making this looking a little bit nicer, I'll just add an end line and run it again. So you can see that calculation is happening. And that pretty much is what it should be. As you noticed, over here in the class shape, I basically defined these two members as protected, not as private. So one may question, okay, why not private and what is going on with the access control? To understand that better, and meanwhile I'm cleaning the code a little bit, let's go back and take a look at the access control and inheritance. A derived class can access all the non-private members of its base class, which in this case we were accessing the protected members. Thus, base class members that should not be accessible to member functions of derived class should be declared private in the base class. So if I would have defined, and let me just go back to code pretty quick. So if I would have defined these guys private instead of protected, and let's try it. Now the access to those guys is actually banned. And as you can see, I immediately get an error that height is a private member of shape, therefore I cannot use it. And if I try to run this, I'm going to get a build failed, which basically is for that reason. So let me just switch this back to protected. So now I can inherit from there, and if I run it again, the build is successful and it works. Speaking of that, we can summarize the different access types according to who can access them in the following way. So, for the same class with the access specifier of public, same class, derived classes, and outside classes can have access to it. So if you define something public, almost everybody has access to it. If you define it protected, the same class has access to it. The derived classes also have access to it. Again, remember when we were writing our code over here, we did that. We defined those as protected, so the derived class down here now has access to it. But the outside classes cannot have access to it. So basically, with putting a member as protected, you just ban the outside classes to gain access to that protected part. And then if you set the specifier to private, then only the same class can have access to it. When it comes to the methods of a class, a derived class inherits all base class methods with three exceptions: constructor, destructor, and copy constructors of the base class, overloaded operators of the base class, and the friend functions of the base class. Based on the fact that we have multiple type of access specifiers, we also have different types of inheritance. When deriving a class from a base class, the base class may be inherited through public, protected, or private inheritance. The type of inheritance is specified by the access specifier as we just explained. We hardly use protected or private inheritance unless the design actually is mandating it. But public inheritance is most commonly used version of the inheritance. And the public inheritance, when deriving from a protected base class, then everything is going to come down as protected to the derived class. And when deriving a class from a public base class, public members of the base class become public members of the derived class. A base class's private members are never accessible directly from a derived class, but can be accessed through calls to the public and protected members of the base class. So to summarize that, public goes public, protected goes protected, and private does not get inherited, but is still accessible through the public or protected members of the class. Protected inheritance. When deriving from a protected class, public and protected members of the base class become protected members of the derived class. So look at the difference. And the public, if you're inheriting a public member, it will be public in the derived class. But in protected inheritance, no matter if they're public or protected, they're going to be protected in the derived class. And in the private inheritance, when you derive from a private base class, public and protected members of the base class become private members of the derived class. So to understand and remember this more easily, look at this. The name of the type of the inheritance, basically in these two cases, is the result in the derived class. And in the case of public inheritance, we just keep whatever we received from the parent class. C++ also supports multiple inheritance. A C++ class can inherit members from more than one class, and here's the syntax. So basically you use the identifier of the class and then derived class colon access space A comma access space B comma and so on and so on. So basically you just list every base that you're inheriting from and use the comma as a separator. Access is one of the public, protected, or private, and would be given for every base class, and they will be separated by commas as shown. So let's go to the code and try an example in this case. So continuing on the example we worked on, I just want to add another base class over here right after the previous one and name it base class paint cost. Let's say we want to have a class that calculates the paint cost for a specific area. So the class identifier, again, this is the base class, so I don't need to do anything special but to define it. So that's my class, and let me just put this so compiler doesn't pick on me. And then I simply define a public method over here, which is going to return an integer getting the cost based on an integer area that I passed to it. And the only thing that this guy does, and let me just scroll it up a little bit, the only thing that this guy does is returns the area which we sent it to him, multiplied by, let's say, 70 or whatever as the price that we decide. So that's as simple as that. Let's look what we have, and let me just change this. Okay, so we have a base class over here called paint cost, which simply has a public method that receives an integer area and returns an integer, which is area times 70 is calculation of the cost, let's say $70 per square feet or whatever. And then we have another base class up here, so that's the second base class, which has what we worked on before. So let me just do this so you can see them all together. There we go. These are my base classes, two base classes, 1 and 2, and then I have the derived class that I used to have. But now I'm going to change this derived class so that my derived class actually is going to be deriving from both of these. So I have the class rectangle, so I'm publicly inheriting from shape. The only thing that I need to do is put a comma here and then define the axis, which is going to public again, and then this time I'm going to get it from the paint cost, and that's the only thing that I need to change in the definition on top and in the signature, and there you go. Now I'm coming down here, and right where I have my calculation happening, I simply set an integer. I create an integer, name it area. Okay, and in this case I'll calculate the area and set it to be a rectangle dot. Remember how we were getting the area? That was the get area function, right? There you go. And now area is that. So the total area is that. Now I'm going to do another cout. And this time I'm gonna put something like total cost is, and guess what I need to do? In this case, I need to use this function over here and calculate the paint cost, which is going to be the rectangle, which is my object, times this time I want to get the cost. So that's going to be get the cost, and for the integer area I'm going to pass the area that I just calculated up there. Okay, and then another end line to make it look nice, and let's run it. And as you can see, I have the total area equals 35, and here is 2450, which is the multiplication of those two together. And that simply is how the inheritance works. So let's do a quick review. We had one base class, which was shape, which was defining the shape with a getter and setter to set the width and height. Then we had another base class called paint cost, which was basically calculating the cost of painting that area with one publicly set getter. And basically we had the derived class, which was deriving from shape with a public specifier and deriving from paint cost with a public specifier, which itself had the area being calculated inside. And we only created an object of this class rectangle. Again, remember, we only had one object, which was an object of this class, but through inheritance was able to access members and methods of these two parent classes. And this concludes this video.